Today I am going to explain about projectile motion. The definition of projectile motion is the motion of an object in a vertical plane under the influence of gravitational force. The projectile motion is two-dimensional motion. It can be discussed in two parts. One, horizontal motion and vertical motion. These two motions are independent of each other. Let's understand the projectile motion through a figure. An object is thrown with the velocity v0 making an angle theta with the horizontal. The acceleration is acting in downward direction. Let's break the component of velocity v0. The horizontal component will be v0 cos theta and the vertical component will be v0 sin theta. There is no force acting in horizontal direction. So, force in horizontal direction Fx equal to 0, which implies acceleration in horizontal direction is equal to 0. Now we can write acceleration in horizontal direction as dvx by dt equal to 0. The derivative of constant is 0. So, Vx equal to constant. Now, Vx here is V0 cos theta. So, V0 cos theta equal to constant. Now, the horizontal component of velocity at point A will be V0 cos theta, at B will be V0 cos theta, at C it will be V0 cos theta, and it will be constant V0 cos theta over the trajectory. The displacement in x direction, the total displacement in x direction from initial point A to final point C is AC, which is known as range of projectile and is denoted by capital R. A to C is the range of projectile. The only force acting on a projectile is the gravitational force, which is acting in vertical downward direction. So, the vertical velocity of the projectile will decrease with time and will become 0 at the highest point of the trajectory. It will again increase and regain the velocity at point C, which is V0 sin theta in downward direction. In the first half of the trajectory, the gravity will oppose the motion, while in the second part, it will support the vertical component of the velocity. The total displacement in y direction, that is from initial point A to final point C, is 0. There is no displacement in y direction. Now, the total displacement from initial point A to the maximum height point B is BD, which is known as maximum height of projectile and is represented by capital H. The time taken by a projectile from initial point A to final point C is known as time of flight and it is represented by capital T. Some important point in projectile motion is the horizontal component of velocity V0 cos theta, the gravity acting in downward direction, and mechanical energy, which is kinetic plus potential energy. Remains constant with respect to time, while vertical component of velocity V0 sin theta, momentum, kinetic energy, potential energy will change with respect to time. Now, kinetic energy at the point of projection is maximum. While the kinetic energy at the highest point of trajectory will be minimum. Whereas the potential energy at the point of projection is minimum, and potential energy at the highest point of trajectory is maximum. Now I am going to drive a formula for time of flight, maximum height and range of projectile. As we know, one-dimensional kinematic equation for constant acceleration are these. We are going to use these formula for derivation. So let's start with time of flight. The time taken to cover the distance is from A to C is known as time of flight. So time taken from initial point A to final point C is known as time of flight and is represented by capital T. Applying the one-dimensional kinematic equation in y direction, the displacement in y direction from initial point A to final point C is 0. The acceleration in y direction is equal to minus g, and time taken from initial point A to final point C is time of flight, which we need to find out. So we are having displacement S, acceleration, and we need to find time of flight. So which formula we should use? This formula is having S, T and A. So we should go with the second equation, applying it in y direction. So Sy equal to Uy T plus half Ay T square. Now Sy is equal to 0 and Uy is initial velocity in y direction, which is v0 sin theta, and T is time of flight, capital T, plus half acceleration is minus g and T is capital T, time of flight. So taking T out and 2 out, it is 2 v0 sin theta minus gt equal to 0, which implies T equal to 0 and T equal to 2 v0 sin theta by g, which is our time of flight. So time of flight depends on angle of projection. For a given velocity v0, the time of flight will increase with increase in theta. So the T maximum is T v0 by g at theta equal to 90. So when an object is thrown vertical, the time of flight will be maximum at that duration. Now we will drive the formula for maximum height of a projectile. So while apply one-dimensional kinematic equation in y direction, initial point A to the highest point B. So the displacement in y direction from initial point A to highest point B is represented by H, which we need to find out. We need to find A to D. So initial velocity at A is V0 sin theta, while final velocity at B is in y direction is 0, while acceleration in y direction is minus g. So we need to find S. We are having U, V and A. So we will go with equation 3 where we are having V, U, A and S. So applying the formula in third equation. So we will apply equation 3 in y direction. So Vy square equal to Uy square plus 2Ay Sy. So final velocity at point B is 0. Initial velocity at point A is V0 square sin square theta plus 2. Acceleration is minus g and Sy is capital H, which we need to find. So H equal to V0 square sin square theta by 2g. So this is the formula for maximum height of projectile. Now H depends on angle of projection. At the given velocity, if theta, H will increase with increase in theta. So H maximum is V0 square by 2g at theta equal to 90. Now I am going to derive the formula for range of projectile. The range of projectile is the maximum displacement in x direction, that is A to C. So applying the 1D kinematic equation in x direction from initial point A to final point C. So the displacement in x direction from initial point A to final point C is R, which we have to find out. Now we are having time of flight from initial point A to final point C, which is equal to 2V0 sin theta by g. We are also knowing that acceleration in x direction is 0. So we are having t, a, and we need to find s. So we will go with acceleration. As we are having acceleration t and s, so we will go with equation 2. So applying the equation 2 in x direction, Fx is equal to uxt plus half ax t square. So ux will put it as r ux is v naught cos theta. T we are having 2v naught sin theta by g, which we derive from the formula of time of flight, plus half ax is 0. So it will become 0. So r equal to v naught square by g 2 sin theta into cos theta. We'll apply a trigonometry. We know that 2 sin theta dot into cos theta is sin 2 theta. So the formula for range of flight is v naught square by g into sin 2 theta. So we are having this formula for range of projectile. So r will depend on angle of projection. So for the given velocity, r will increase with increase in theta. We have derived the formula of range. Range is equal to v naught square by g sin 2 theta. We can also write it as v naught square by g sin 2 90 minus theta. In trigonometry we know sin 180 minus 2 theta is sin 2 theta. So let's suppose if we are throwing an object with an angle theta, the range will be equivalent when it is thrown from an angle 90 minus theta. Let's suppose theta equal to 30 degree. So 90 minus theta is equal to 60 degree. So the range covered by this after the range covered by object at theta equal to 30 is equal to range covered by object at theta equal to 60. The range will be same. So now we will find the maximum range of a projectile. So R max will be when v naught square by g and the sin 2 theta will be maximum. So when sin 2 theta will be maximum? When it will be 1. The value will be 1. So v naught square by g will be the maximum value. Now sin 2 theta will be maximum at sin 90. So 2 theta equal to 90. So theta will be 45. So R max will be maximum when theta is 45. Now we will understand the relationship between the maximum height and the when the range is maximum. So when range is max, h equal to v naught square 2g sin square 45. 45 because r is maximum at angle 45. So by putting the value of sin 45 1 by root 2, we got v naught square g into 1 by 4. So v naught square g is our r max. So at maximum range, the maximum height of a projectile will be r max by 4. Let's understand the equation of trajectory. The equation of path followed by the projectile is known as equation of trajectory. Let's take an arbitrary point P, x, y at time t. The distance covered in x direction, horizontal direction, in time t is x, while the distance covered in y direction, vertical direction, in time t is y. Now, the initial velocity in x direction is v naught cos theta, while the initial velocity in y direction is v naught sin theta. Now, the displacement in x direction from initial point A to arbitrary point P is x, while the displacement in y direction from initial point A to arbitrary point P is y. The acceleration in horizontal direction, x direction, is 0, while the acceleration in y direction is minus g. Now apply one-dimensional kinematics equation in x direction direction from point A, initial point A, to arbitrary point P. Now we are having velocity, initial velocity, displacement x, v, s and acceleration. So which formula we should apply? We are having s, we are having initial velocity, we are having acceleration, we are having t. So let's go with equation 2. Applying equation 2 in x direction equal to ux t plus half ax t square. Now sx from point A to P is x. Ux is our v naught cos theta. We are having ax, acceleration as 0 t square. So this applies, it got 0. So t equal to xy v naught cos theta. So this is our equation 1. Our objective is to find the relationship between x and y. So now we will apply the formula in y direction. So let's apply one-dimensional kinematic equation in y direction from initial point A to arbitrary point P. Again we will go with the second formula. So Sy equal to uyt plus half ay t square. Now Sy is equal to y. Sy is equal to y. Uy is v naught sin theta. Let's take, okay, we are having t here, plus half ay is minus g t square. So this is our second equation. Now we will put the value of t from equation 1 in equation 2. So let's put value of t from equation 1 in equation 2. So we are having y equal to v naught sin theta. The value of t is s by cos theta, v naught cos theta, minus g by 2, again x v naught cos theta square. So now we are having y equal to v naught will cancel, so x sin theta minus g by 2 x square v naught square cos square theta. So this is the equation of trajectory. Now we are having y equal to c1x minus c2x square. So this is the equation of parabola. So this is the equation of trajectory. Now we will write the equation of trajectory in terms of range. So y equal to x, we will take tan theta x tan theta as common. So x tan theta 1 minus 1 by 2 g x v naught square theta dot tan theta. So tan theta is sin theta by cos theta. So we can replace tan theta by sin theta by cos theta. Now cos theta, 1 cos theta will cancel from here. So cos theta. Now we know, okay, we'll go with the second, again we'll write this equation as x tan theta 1 minus g by x 2 v naught square. We will take this 2 here, 2 sin theta cos theta. Now while applying the trigonometry, we can write 2 sin theta cos theta is equal to sin 2 theta. So we can replace this as sin 2 theta. Now we can take the g here. So let's remove g from here and we can take the g in denominator, and now we know that v naught square theta by v naught square sin 2 theta by g is equal to r. So we can write y equal to x tan theta 1 minus x by r, where r equal to v naught square sin 2 theta by g. So this is the another equation of trajectory in terms of r. Just now we derived two equations of trajectory, one in the terms of r and one in the terms of velocity and gravitation g. So let's suppose we have a question y equal to 16x minus 2x square, and we need to find range. Since the question is asking for range, we'll go with the formula which is having range in it. So we'll go with this formula. Let's apply the formula. So how we have to take, we know that x tan theta is common in this formula. So we will take, and the second term is as 1. So we'll make this first term as 1. So y equal to, we'll take 16x as common. So it will come as 1 minus 2x square by 16x. So this x will get cancelled. Here it will come as 8. So y equal to 16x 1 minus x by 8. Now we'll compare this formula with this equation. So we'll come to know that r is equal to 8. So r is equal to 8.